And here is a standard radio image of it. Although it's a lot brighter, a lot of the detail has been lost. Now compare it with one of the new high-definition images.
How old is the universe, really? For decades, we've had a number written in textbooks that seem to define our place in the cosmos. 13.8 billion years. But what if that isn't the full picture? What if the story of our universe, its scale, and its beginnings are far more complex than we believed? The James Webb Space Telescope is now sending back images that are challenging our most fundamental assumptions. It's forcing us to redraw the map of the cosmos, revealing a universe that built itself faster and on a grander scale than we ever dared to imagine. We thought we knew the scale of things. It's becoming clear we were just getting started. For a generation, our view of the deep universe was defined by one instrument, the Hubble Space Telescope. It was our eye on the cosmos, and its discoveries were legendary. Hubble gave us the iconic deep fields, images of thousands of galaxies packed into a sliver of sky, revealing a universe of unimaginable vastness. It helped us pin down the age of the cosmos to that familiar 13.8 billion year figure. This was the established picture, a universe that began with a Big Bang and then, over billions of years, slowly allowed gravity to pull together wisps of gas into the first stars and then the first galaxies. The early universe, we believed, must have been a quiet, sparse place. It was a neat, orderly story that we felt we largely understood. But this comfortable picture had large portions marked, "Here be dragons." There was a boundary we couldn't see past, a cosmic dark age whose secrets remained locked away. Until now. The James Webb Space Telescope is not just an upgrade to Hubble. It is a fundamentally different kind of observatory. Its massive 6.5-meter golden mirror is designed to capture the faintest, most ancient light in the universe. Light that has been traveling for over 13 billion years. This ancient light is so stretched by the expansion of the universe that it's no longer visible to our eyes or even to Hubble. It has become infrared light, the glow of cosmic heat, and Webb is a time machine built to see it. It can peer through the dense cosmic dust clouds that blinded Hubble, looking directly into the stellar nurseries and galactic cores where stars and planets are born. If Hubble opened a window to the cosmos, Webb has torn down the entire wall. And what it's showing us on the other side is not the universe we expected. The first rule of the old cosmic playbook was that structure takes time to build. After the Big Bang, the universe was a smooth, hot soup of particles. Models predicted that the first galaxies would be small, fragile, and incredibly rare. Finding them would be like searching for a single candle in a fog-filled stadium. Instead, Webb found a surprising abundance of them. In deep-field surveys like the Cosmos Webb program, astronomers have found far more early galaxies than many of our most advanced models predicted. And these aren't just faint smudges of light. Many of these galaxies are far more massive and evolved than they have any right to be. This discovery has placed cosmologists in a strange position, challenging our timeline of cosmic construction. It means the universe built its large-scale structure with shocking speed. The quiet, empty dawn of the cosmos may never have existed. Instead, it was a frantic, brilliant blaze of creation happening far earlier than we thought. On the grandest of scales, our universe is not a random scattering of galaxies. It's organized into a colossal structure known as the cosmic web. Unfathomably long filaments of dark matter and galaxies separated by vast, empty voids. We've mapped this web in our local cosmic neighborhood, But we always assumed it was a recent development. Webb has proven that assumption wrong. Astronomers using Webb discovered a gigantic filament of 10 galaxies stretching over 3 million light-years long. The truly mind-bending part: we're seeing this structure as it existed just 830 million years after the Big Bang, when the universe was only 6% of its current age. Anchored by a brilliant quasar, this is one of the earliest strands of the cosmic web ever seen, the primordial skeleton of the universe already falling into place. This discovery is profound. It tells us that the blueprint for the cosmos was laid down almost immediately. Galaxies didn't form in isolation. They were born and threaded onto this pre-existing cosmic superhighway. If you're enjoying this journey to the edge of our understanding, and if the sheer scale of these discoveries is as mind-blowing to you as it is to us, consider subscribing. We're just getting started, and you won't want to miss where Webb takes us next. While Webb is revealing grand, orderly structures on the largest scales, it's also showing us that up close, the early universe was often a place of pure chaos. Many studies of young galaxies revealed they were not the majestic spinning spirals we see today. They were clumpy, turbulent, and irregular places, constantly colliding and merging. But here lies another of Webb's great paradoxes. Out of this expected chaos, Webb also found something astonishing. Alaknanda, a stunning grand design spiral galaxy complete with beautiful sweeping arms, seen when the universe was just 1.5 billion years old. Finding a galaxy this mature, this early, is like finding a fully grown oak tree in a forest that's only a few years old. It challenges every model we have for how quickly galaxies can settle down into the elegant structures we see today. The early universe was simultaneously a messy battlefield and a workshop capable of producing stunning masterpieces far ahead of schedule.
For years, a shadow has been looming over cosmology, a puzzle known as the Hubble tension. It's a fundamental disagreement about how fast the universe is expanding right now. When scientists measure the expansion rate using the physics of the early universe, they get one number, around 67 kilometers per second per megaparsec. But when they use nearby objects, like stars and supernovae, they have often measured a higher value, closer to 73. It was hoped that Webb's precision would settle the debate. The result was more complex and interesting. Recent work led by Wendy Friedman, using Webb's incredibly sharp infrared vision to recalibrate distances, has found a value of around 70. This new measurement helps to ease the discrepancy, bringing the two values into closer statistical agreement. Webb didn't make the problem disappear, but its more precise data suggests the crisis may be less of a crack in our foundational model than more of a subtle puzzle we are now equipped to solve. So let's step back and truly appreciate the new scale of the universe that Webb has revealed. Hold up a single grain of sand at arm's length. That tiny, insignificant patch of sky is the size of Webb's deepest images. And in that single grain of sand, the telescope reveals thousands of galaxies. Not stars, but entire galaxies, each containing billions of their own. Many of them are just faint red smudges, their light having traveled for over 13 billion years to reach us. Webb has officially identified galaxies like Jade's GS Z13, which we are seeing as it was just 330 million years after the Big Bang. The light from that galaxy began its journey to us about 13.47 billion years ago. But the scale isn't just about distance, it's about structure. While Webb peers into the beginning of time, other telescopes are mapping the colossal structures of today. Recently, astronomers found a cosmic filament roughly 50 million light-years long, containing hundreds of galaxies that appear to be rotating together as a single coherent structure. This suggests the galaxies don't just spin on their own. They are caught in cosmic whirlpools of a size that defies all human comparison. The James Webb Space Telescope hasn't just given us prettier pictures. It has initiated a revolution. It has revealed a universe that built its structures faster, earlier, and on a grander scale than we ever thought possible. It has shown us the chaotic birth of galaxies alongside the impossibly early emergence of order. It has provided crucial new data that reshapes our understanding of cosmic expansion, forcing us to refine the very laws we thought govern the universe. The universe is not just vast and old. It is older in structure, more crowded in its youth, more extreme in its scale, and profoundly more mysterious than we ever knew. We are standing at the dawn of a new cosmic age, looking at a map that is being redrawn in real time. And the most exciting part? This is just the beginning.